Good afternoon, one and all present here. I welcome all the participants to this third day short-term training program on nanotechnology and functional materials phase 2. Now we are going to start this third day second session. Once again, thank you for joining with us. Now let me introduce our eminent resource person, Dr. Rajlakshmi Ma'am, Associate Professor, V8 University, Vellore, Tamil Nadu. In 2015, she has completed her doctoral degree in production engineering from Sri Venkateswara University, Tirupati. In 2003, she has done a master's degree in industrial engineering from Sri Venkateswara University, Tirupati. She is having a total 17 years of teaching experience, and out of which nearly 10 years of research experience. She has been authored and co-authored for more than 50 refereed journals and 30 conference proceeding papers. She had completed a funded project from DST Serve entitled with Improving the Performance of WEDM by Developing Wire Workflows. About almost 5 research scholars have completed their doctoral degree under her guidance. She is having collaboration with many professors from various institutes and coordinates for several masters and research projects on materials, production, and optimization area. Her main research interests are related with advanced machining, optimization, development of hybrid algorithms, Industry 4.0, development of materials and processing techniques, and tool design. She is having membership with IISc also. We are honored with your presence, ma'am. I request, ma'am, you please continue with your session, ma'am.
Yes, sir. Sir, thank you so much for elaborated introduction about me. And first, I must thank Chandrasekharan sir, HOD, Department of Mechanical Engineering, SV College, and other coordinators like Rajesh sir, Vamsi Krishna, and I know many of your faculty, Guru Mahesh, Ajay, and other colleagues. And sorry to spell very few names. I thank each one of you for giving the opportunity to present the lecture during this STTP on nanotechnology and other functional materials. Hope I'll give some useful information during this 2-hour session. Yeah, later on we can continue even if you have any doubts in future for the research projects or for other research activities. I'll try to start my presentation. Sir, is it visible? Screen share?
Yes, ma'am. Yes, ma'am. Perfect. Yes, this is a presentation mode. Okay, ma'am.
Yes, sir. Yes, sir. Yes. Okay. Now I'm going to give very brief, not very detailed because of the time duration. I can give you very brief, but I'll try to cover major areas where nanotechnology will be useful, especially for developing material properties. Irrespective of the field, I'll try to cover almost all the fields, what properties can be improved with the help of nanotechnology, how it is impacting on our day-to-day life, and also even professional life, like for industries and other means non-manufacturing sector also. So myself, Rajlakshmi, already sir introduced. So working as associate professor in mechanical engineering, V8 Vellore. So here, when it comes to nanotechnology and with respect to the term called nano, it is actually you people are organizing around 10 days, 7 to 10 days of workshop on nanotechnology. So you people may think that why so big discussion on the term called nano? It is already very small. So is it necessary to discuss or is it necessary to go this much of this means time consumption or spending time this much on the term called small? So it is definitely necessary. So now whatever situation currently we are facing, it is completely unexpected. For last 4 to 5 months. So otherwise, I will be at your campus. Then we'll be having face-to-face discussion for this particular one. So whatever situation we are facing today, that is called COVID-19 or Corona, whatever it is. So it will be when it comes to size of the coronavirus, it is very, very small. It is about 120 nanometers. But how big the world? What is the size of the world? So even though the size of this
Excuse
coronavirus,
me, ma'am. Sorry to
yes, sir.
disturb you. Ma'am, it
Sir?
is not in presentation mode, ma'am. Please.
Okay. Is it fine, sir, now?
Okay, ma'am. Only thing is, you just press F5, it will become a presentation mode. That's it.
Yes, sir. That is what I'm doing. Yes, sir. Slideshow only, no?
Slideshow.
Yes,
No,
sir.
it is
F5
not.
is
No, in that slideshow, it is not there.
it is not visible, sir.
It's visible, ma'am.
Okay.
Only thing is, we are seeing the further slides also in the side. It is not in the slideshow. Only in the slide it should come. No?
I am presenting with slideshow only, sir.
Okay. Okay, ma'am. Please, ma'am. Okay, you can proceed, ma'am.
Let me check it.
Please press F5, F5, madam.
Yes, sir. Then, sir. Yes, sir. Yes, sir. Still, other slides are showing, sir.
Yes, ma'am. Yes, we are seeing your next processing slides also. We are seeing in the left side. From or else we go with from beginning. You press it, ma'am.
Yes,
Present.
sir. That is what now I'm trying with
Okay.
the screen sharing only, sir.
Okay. Okay. Okay.
Is it okay, sir? Now?
Not yet, ma'am. Not yet.
One second, I'll screen share.
Yes, ma'am, yes.
Sir, now?
Yes, we are seeing your screen, ma'am. You are presenting, but
Okay.
we are seeing your upcoming slides
Slide.
also. Yes, yes, yes.
I put it in slideshow mode only, sir.
Okay, ma'am. No problem. You can proceed.
Yes, sir. Yes, sir. Based on the current situation, even though the virus size is so small, but still it made all of us, the entire world, completely to sit in lockdown position, and it has lot of impact on our entire manufacturing sector and other non-manufacturing sectors also. So that is why we should not be too careless about the term called small. It will show lot of impact on very big industries or even big organizations or even in big products also, whatever it is, big situations. So that is why even the term nano or small, so even though it means or define in terms of small or minute or vast, whatever it is, so it has a lot of impact. It has it has some it will show maximum impact or a lot of impact on many big issues
Excuse me, ma'am, we are not hearing your voice, ma'am. I request the participants, please wait. We are having some network problem seems. Because of network problem, our resource person was left, and we are expecting within 2-3 minutes he will join again. Dear participants, just now you have contacted resource person. She will join within 2 minutes. Please wait. Yes, ma'am. We are seeing your presentation screen, ma'am. Ma'am, I think you are in mute condition, ma'am. Please unmute.
is it fine now?
Yes, ma'am. Yes, ma'am.
Okay, sir. Okay, sir. That is what, since the term called nano, even though it is very small, so we need to give maximum care to understand the impact of the particles, which are very small in size, how it will be impacting on various properties, mechanical and non-mechanical properties, and how it will be showing impact on the final product features and functioning also. So that is what today I'm going to elaborate my discussion on how nanoparticles or nanotechnology will be impacting various mechanical properties of the products, so which we are experiencing in our day-to-day life and also for the industries. Already I have mentioned that, so even though the size of the coronavirus, so which is about 120 nanometers, even though size is very small compared to human body size, but still entire world is kept locked down. And if the situation is not like this, I will be at your campus and we'll be having face-to-face discussion. But it is completely unexpected one. That is why we should not be very careless, or we should not be we should not even neglect the things which are even small or negligible in size. So that will be having lot of impact on majority of the products and features, and also in different fields also. So let us see one by one how these nano size will be impacting on the properties, and at the same time will be impacting on the manufacturing processes, and how it will be impacting on various industries, and both in manufacturing and non-manufacturing sectors. So already I have mentioned, so what you people might be having a lot of knowledge or already gathered knowledge based on earlier sessions, and people might have introduced what is nanotechnology, why it is required, and what are the various applications. But still I'll go very brief what exactly nanotechnology. Already I have mentioned it is a term called nano, means or nanotechnology. It is completely related to molecular manufacturing. That means we are completely focusing on the matter. Matter means material. So how the matter or the particle or size of the matter plays a role on properties of the product which you are trying to manufacture with the so-called matter. It is whatever may be the material, if it is a steel or aluminum or copper or fabric or whatever it is. So how the particle size in a particular matter will be impacting on the properties of the product which you are trying to manufacture with the steel or with the copper or with the fabric or any other organic or inorganic material, so whatever it is. So nanotechnology, we can say indirectly or directly, it is like completely like a matter. It is completely related to matter, and we are trying to modify the matter size so that it will be impacting on the properties which will be helping for improving the properties of the particular product in a positive direction. So that's why we are trying to manipulate the size of the particles of a particular matter. So whatever may be the material, it is no need to bother about the material. So any kind of material, in which direction and to how smaller we can try to manipulate the matter particle, so that the small sized particle will be influencing the properties of the product, so which we are expecting as an end product, and how to what extent the particular end product will be helping or will be satisfying the customer requirements or the manufacturer requirements. So we can completely say that it is completely related to matter, or it is totally depending on molecular manufacturing. Already everyone knows that nano means small or minute, and we can say that it is very hard to imagine how small the nanotechnology or nanoscience or nanoparticle, whatever it is. But still, the impact is a big. So we can't even imagine how big it is when it compared to the term called nano it is. So that is why we can say that is why we should not be very careless, or we should not neglect any small term, particle, product or the situation, whatever it is. Even small fact or small particle or small small situation, so our small idea, whatever it is, it will be impacting on the society, on the manufacturing field to a greater extent. So I'll try to give you one example which is completely irrelevant to the topic which we are discussing today, but it will be easy to understand with that particular example. So as all of you know that our Honorable Prime Minister has started a mission called startups. young startups. So India already, we know that India is second largest populated country in the world, and the resources are not very less, but according to the population, the resources whatever is available in our country, which may not be sufficient to satisfy all our requirements, even basic needs also. So the only strength to our country is human source. So that is why our Honorable Prime Minister focused on how to utilize the human source so that the basic needs of majority of the group of people will be satisfied, but at the same time, people will try to extend the help to other other persons in terms of employment. So with that particular motto, Prime Minister has started a mission called startup. So why I am giving this example means the term called startup. Startup means it is not possible to, even though the person is a prime minister or whoever it is not, he is also a human being and he cannot do any kind of magic or wonders. So whatever resources are available, only with his managing skills, people will try to improve the facilities and will try to means depends on their capability, will try to utilize all the resources. So with that particular intention, instead of leaving all the graduates by showing less number of job opportunities, why can't you provide minimum kind of financial support to the young graduates so that they'll start their own business or their own ideas, which will be helping for their own employment. Once the idea is succeeded, the people can try to provide they can try to provide employment to other graduates also. See here, why I'm mentioning this particular area means, so the startup is a small fund, very less fund it is not big. And even though he is the complements head of the country, but still he cannot provide financial support to all the people whoever wants to start the business in a huge amount. So with that particular to overcome the particular difficulty, so instead of providing huge amount for one particular person to start their business, let this huge amount is split into small amounts. So then it can be distributed to n number of graduates so that they can start their own employment. Later on in future, these entrepreneurs or startup owners can provide employment to other people also. So why I'm already I have mentioned this example is technically irrelevant to the topic which we are discussing, but why I'm mentioning is that startup is a small amount. This small amount showing greater impact on employment rate in India. So people are trying to get the financial support from the government to start their own business, but with least possible amount. It is not a huge amount. So that is why this is one example which we can consider that the term small will show maximum impact or greater impact in various situations positively. That is why I have taken this particular example, even though it is completely irrelevant to the particular topic, technically especially. That is why please don't please don't neglect or the least bothered about the term called nano. It is having lot of impact on big organizations. Already you people know what is nano means. It is 10 to the power of 9 meter. So there are so many examples of it is. So we can say small thing, if you take a bolt or nut or any other small screws. So what is the size of the screw means? Simply you will say that it is only 1 inch or half inch. But when you are trying to talk in nanometers, in nano scale, so it will be a big number. So no need to take all these non-living objectives. Let me take my own example. So suppose my height is 5.2 inches. So if I say, people may, of course, I may feel that I'm little short. But when I'm trying to express my height to others, I can say that I am around, it will be around in centimeters, it will be around 150 to 153 centimeters. But in terms of nanoscale, I can say that I am 153,000 crores nanometers height. So it will give some positive or better reference, right? So that is why means when it comes to expressing some things, it will give positive impression or impact on the particular situation, so that we can impact even on a nanoscale also. Even whatever newspaper we are reading every day, so it is around 1 lakh nanometers thick. But imagine that how thick it is. When it comes to nanoscale, it is too thicker it is. Similar way, there are so many examples to measure or to give examples, especially in terms of nanoscale dimensions. So here, what exactly nanotechnology means, already I have mentioned that. So it is a study related to molecular engineering or matter. So any product if you take or any material if you take, it is a matter which will be consisting of some particles. So what about the size of the particle? With respect to the size, how it is impacting the properties of the particular matter, and based on the matter, when you are trying to utilize the particular material for making some product, during functioning of the particular product, how it is impacting, how the functioning will be. So in terms of various mechanical or non-mechanical benefits. So that is why nanoscience or nanotechnology, we can directly say that it is a molecular engineering. So it will be completely depending on nanotechnology means we are using some technical skills in terms of fabrication of nanoparticles. But thing here is we are trying to manipulate the size of the particle. So size of the particle, then we are trying to observe how it is impacting on the properties of the particular material. So once the material is used for fabricating into different products or in different shapes, then how the product will be responding, means according to the manufacturer's requirements. So that is called nanotechnology. It is completely related to material, particle or matter. We are trying to manipulate the matter particle sizes in different sizes. Then we will be observing how the size of the particle will be impacting on various properties of the particular material when it is utilized in various industries or fields, whatever it is. No need to discuss too technically, very common and general example. So when you are trying to pack the luggage, if you are going for some trip, all of us during some, of course, due to this COVID, many of us missed so many trips during this summer. When you are trying to factor, if you are going to a trip, so that at the moment of boarding into the bus or train or flight, whichever mode of transport, even car, whatever it is, and after reaching the hotel or the place wherever you want to go, then the way how you are refreshing, the way how you are enjoying, the way how you are capturing your moments at a particular place, and the way how you are refreshing with the music, and what kind of devices you are using. So each and every aspect in our day-to-day life, which is directly connected to nanotechnology. So wherever you are boarding, either train or bus or flight, whatever it is. So what kind of nanotechnology is impacting on manufacturing of the aircraft? So what are the various parts, how this technology is impacting the functioning of the aircraft, that you can check it. So then wherever you have board out, how the nanotechnology is used by the resort people or hotel people. Wherever you are trying to capture the images with your camera or mobile phone, whatever it is, what kind of nanotechnology is adopted in your mobile phone or camera or whatever devices you are trying to use. So then wherever you are trying to refresh by listening to music, whatever DVD player or CD player or any other pen drive, whatever you have to use for listening to music. So storage devices or any other thing. So what kind means how the particular device is influenced by nanotechnology. So at each and every point or at each and every minute of our life, it is completely influenced by nanotechnology. What is the thing? But the only thing is we are not realizing or recognizing that the comfort, whatever we are enjoying, the convenience, whatever we are feeling at the workplace or at the home. So most of the comfort and convenience are the benefits, whatever we are enjoying today. So most of these things are influenced by nanotechnology that we are not aware of. So that is why here, please don't think that this nanotechnology means it is only for one particular group of people, which is not related to completely to our area, to our field. It is related to each and every area. That is why I have mentioned. Please don't again misunderstand that the term technology, it is only for engineering field. So it is related to even non-engineering departments also. This nanotechnology is mostly influenced by even non-engineering departments, especially medical sector. It is. So that is why here nanotechnology means it is influencing at each and every part of our life, both professionally and also personally. So here, how these nanotechnology or how, what are the applications, what are the areas where you can find this nanotechnology means, it will be covering almost all the fields which we are experiencing with various types of services and products from various departments. You can see here energy storage. So, lot of impact on nanotechnology. I'll explain you what are the properties which are improved with nanotechnology related to energy. And defense and security sections, of course, there is a lot of impact. Materials and metallurgy, of course, nanotechnology is completely related to this materials and metallurgy only. Then electronics, optical engineering, biomedical and drug delivery, food industries, agriculture, cosmetics, biotechnology, and textile. Each and even transport. So each and every organization or department or field, directly or indirectly, it is completely depending on nanotechnology for enhancing their processes, manufacturing processes or other non-manufacturing processes. So that is why this, even though the term called very small, it is covering its impact almost all the fields which we are experiencing the comfort or convenience, whatever we are experiencing today from various departments. It is all because of nanotechnology only. So which is making the life more and more comfort, which is making the life more and more convenient also it is. And at the same time, which is helping the manufacturers to reduce the cost by improving the life of various tools or products or machineries. So because of this nanotechnology only. So let us see why nanotechnology means. Here already I have mentioned, it is showing lot of impact on human being life. Not only now, it is not even a new technology. That is what I just want to clear. Nanotechnology, people may think that it is a new technology which is invented recently. No, people have started doing research on this nanotechnology, nanoparticles, nanoscience in various fields. And it is actually centuries back old technology. I think most of you are aware of Siddha medicine. So if you observe the particle size of Siddha medicine, so it was completely nanotechnology one. So here it is not only Siddha medicine, even other medical field, biological, pharmaceutical industries, people have adopted this nanotechnology long back, but without awareness, and it was not coined as nanotechnology during that time. It is. Okay. So it is expanding even very rapidly into different fields, and people are concentrating on in-depth research for finding new inventions and innovations related to nanotechnology, especially related to improving the properties of the materials, both in mechanical and non-mechanical fields. So it will be impacting almost all the properties. For example, it will be improving the strength. And one of the important feature with the nano, term called nano means, since the size is very less, obviously weight will be less. Whichever industries or fields are expecting the materials with the low weight, this is the one best option. You can try to fabricate the products. Better to go with the material which are lighter in weight without compromising the strength. Strength to weight ratio, it will be showing maximum, nanotechnology showing maximum impact on improving strength to weight ratio properties. With this particular feature alone, remaining mechanical properties are impacting or moving towards means positive direction to a greater extent. Not only mechanical properties, even other properties also impacting because of this strength to weight ratio feature alone it is. So it has lot of impact on other sectors also. So already I have mentioned, it is not only related to engineering, even non-engineering sectors also it is completely related. If you observe whatever clothes you are wearing, that is garments, whatever sunglasses you are wearing, whatever computer devices you are using, whatever cleaning products you are using at your home. So all these day-to-day products, which is compulsory in our day-to-day life. So all these are at one place or other place. These products were manufactured by using nanotechnology only. So, and when it comes to introduction of nanotechnology to various fields, again I am mentioning that it is not a new invention. It is old back, means centuries back invention only. But only thing, we were little late in adopting this particular technology to various fields. Actually, we have missed a lot, especially in manufacturing sector, since we were unable to recognize the impact of nanotechnology, especially in manufacturing process or other fields also. So that is, anyway, people now alert towards implementing this nanotechnology to various fields for getting the benefits, whatever is possible because of this nano, the term called nano it is. So let us see, we'll move towards the actual topic or the content what I have thought of presenting today. So how this nanotechnology will be useful for development of various material properties. Material properties means we can classify in many ways. So these properties, mechanically, how the properties will be getting changed, thermally, how it is impacting, chemically, how it is impacting, what about electrical properties, what about thermal or energy related activities. So let us see one by one how this nanotechnology will be helping for improving the properties of various materials or for developing the materials. So already I have mentioned first thing, because majority of the products whatever we have taken are during the usage or during the functioning of a particular product. Most of the products due to the environment, the place where we are using, the situation where the product is adopted for the functioning, whatever it is, there will be a chance of mechanical impact on many products. When the product is experienced with many loads, especially mechanical environment, how it is getting sustained to improve the means in terms of protecting their own properties, how the product is sustained even though it is impacting its mechanical environment. So what is the reason behind this? How we are able to use the product even though it is impacting or even though it is undergoing various mechanical factors or loads or environment, whatever it is. What exactly helping the product in terms of mechanical environment to sustain their own properties or to sustain or to function in a proper manner, what exactly manufacturer represents. When it comes to mechanical properties, all of you aware, we will be trying to measure the mechanical properties of any material in terms of these 10 parts. We can measure these 10 parameters, which will be giving how mechanically how good the particular product. So we can measure the brittleness, and we can measure the strength of a particular product, plasticity, how hardened the particular material, how tougher the particular material, what about the fatigue strength, elasticity, ductility, rigidity, and yield strength. So these are the common mechanical properties. So when you have taken a product, so whatever it is, for example, if you take your mobile phone, so you can ask immediately, mobile phone is an electronic device. How it is related to mechanical things? Of course, we need to think when you are calling in your mobile phone. So all of a sudden, if it is fallen down means there is some impact. So it is a mechanical impact only. How the product, how your mobile phone is sustaining with this mechanical impact. So when you are trying to, by mistake, if you are trying to place huge object on your mobile phone or laptop or whatever it is, so then how it will be sustaining its properties or life, even though it is impacted with a huge load. So here you have to check it. Please don't consider how the part is functioning. So even though it is electronic product or computer related product, whatever it is, finally, first of all, it should be having certain mechanical features. Then only it will be functioning properly with other accessories, adding up other accessories, so that value will be added to the particular product. So when it comes to metal, especially traditional materials, how this nanotechnology will be helping to improve all these kinds of mechanical properties. So the nanotechnology not only impacting on materials, it is even showing impact on inorganic, that means non-metallic materials also. So how the, especially related to brittle materials. So when it comes to brittle materials, there is no any kind of property such as plasticity and toughness. But still, how these nanotechnology will be helping the properties of non-metallic materials. And other than metallic and non-metallic materials, we are even using some organic materials, so which are flexible materials, but they don't have any kind of properties such as brittleness and rigidity. So if you take nowadays whatever devices you are using, especially electronic devices. So for example, if we take the laptop, so we can completely fold it. Now the design is the product is designing in such a way that it can be completely folded and we can keep it in our pocket also. In such a way the design is making. So how this particular design is possible? Is it what kind of technology? Do you think that only technology or machining will be allowing the manufacturer to design the product in various scales? Definitely not. Of course, technology will be helping to manufacture the product at various scale, means at different sizes and shapes. but it will be allowing, technology will be only supporting, only for supporting purpose. But if you have a design of fabricating any product which is highly flexible in all the directions, either to fold, bend, whatever it is. So in that case, technology will be supporting you to fabricate according to your requirements. But finally, when it comes to, but how feasible it is to fabricate, even though there is a machining support, means it is completely depending on the particle size of a particular material. So how flexible the particle, how how small the particle, how flexible the particle, so that the particular particle size will be allowing the manufacturer to fabricate the product so that it can be flexible. As an end product, it is flexible to move, bend, what actions you are planning to do. So it can be done because of, only because of the particle size of a material which you have used for fabricating of a particular product. Okay, so all of you knows, I think, so Indian, especially in weaving the saris. So most of you are aware that one person had woven the sari which can fit in matchbox. So now, can you give the reason? Is it just because of the skill of the weaver, or because of the fabric particle size? It is definitely because of fabric particle size. So the particular person try to weave the particle or fabric with very less small, means small size particles. Because of flexibility in fabric particle, he is able to fold to a very nano level or very slow level, means very less level. So that is why it is able to fit. Because even nowadays, even fabric or garment industries, they are trying to adopt nanotechnology to fabricate or to manufacture various clothes or fabrics which can fold in any different directions. Then especially during the travel or long travel, even if you open your shirt or any of your dress, so no need of ironing. So even though it is packed for a long time, and the bag is kept in and around, even in the flight or wherever it is, and it is impacted with all kinds of efforts, external efforts, but still after opening your bag, when you are about to wear your shirt or dress, no need of iron, because that much flexibility is giving stiffness. So it is, people are trying to manipulate the matter or particle which will be helping to reduce the work, or which will be helping to improve the comfort to the manufacturer and also to the customer. So that is why here, how this nanotechnology will be helping, especially to mechanical properties, means all mechanical properties, one way or other way, it is completely related to microstructures. So once there is a change in microstructure, automatically properties also will be getting changed. So this nanotechnology or nanoparticles, especially related to grains, these nanograins or nano-sized particles will be impacting on structural properties. So once there is a structural changes, so then automatically it will be leading for improvement in mechanical properties. So already all of us knows that the effect of grain size on mechanical properties of nanomaterials is mainly reflected in microstructure only. So how to change this microstructure so that mechanical properties will be improved? How nanoparticles in a microstructure will be impacting on improving the mechanical properties. So if you observe nanoparticles which have considerable size effect and have high surface activity, so with this particular one, the matrix, whenever the matrix is forming, especially in a particular material, so because of small sized particles, gaps will be completely filled. So there is no any gap between the molecules or between the grains. So because of complete filling in a particular matrix, automatically pores will be reduced. If there is no pore, or if there is no porosity, automatically density will be improving. So because of this dense relative density, which will be leading for improving mechanical properties. So that is why here it is completely related to the microstructure. Nanotechnology is completely related to matter or molecular engineering only. And addition of nanoparticles can even reduce the size of crystal grains, which promote the densification of the materials and reduce defects such as pores. So if there is no pore, automatically hardness means the properties will be getting improved. So if the porosity is decreased, automatically hardness will increase. So with respect to hardness, remaining mechanical properties also will be getting improved. So if you observe the pinning effect of nanoparticles, which will be improving growth of grains during the sintering, and which will be inhibiting abnormal growth of crystal grains, and it will be limiting the shape so that the grains inside the material exhibit reasonable shape and size also. Means it will provide maximum flexibility to the material to fabricate into any shape and size also. Easy to fabricate because of this particular microstructure, that you have to check it. And fine grains can inhibit even cleavage fracture of the material, so that mechanical properties of the materials even can be improved. It is. And if you observe, it is one of the example related to nanoparticles, addition of nanoparticles, which will be improving the microstructure. You can see here. So if you observe the first A, B, C, D figures, so it is a addition of nanoparticles to the base metal. After addition of certain percentage of nanoparticles, how the structure is changing, you can check it here. So with respect to A, if you observe, there is no nanoparticle addition. So B, 4% of nano alumina is added here. So then here it is, so 20%, then 40%. You can observe the microstructure here. So how the grain size and how the pores are completely covered, how the gaps are completely covered. So based on this, you can observe. So if there is no gap in between the molecules or grains, automatically porosity will be getting decreased. So once there is a, if the porosity is sometimes even with extra addition of alumina, sometimes it will be moving in a negative direction. So which will agglomerates, increasing the porosity, automatically properties also will be getting decreased. So that's why we should be very careful when you are trying to add or reinforcing the base metal with some kind of reinforcement materials. You need to check what is the range of proportion to improve the properties, especially. Further, you can work on modeling it is. So what is that? You can work you can work on mathematical modeling that regarding the mechanical properties with addition of particles or reinforcement with other nanoparticles to the base metal, so that how the properties will be getting improved. So once you do modeling, then you will be having idea that what is the range of proportion of reinforcement with the base metal, so that properties will be moving in a positive direction or in an improved direction. So at the same time, it is having excellent mechanical properties due to volume, surface, and quantum effect of nanoparticles. So surface related to surface means because of nanoparticles, surface areas will be increased. It is. So for example, you can see here, even again I'm giving very general example, not very technical. It is when you are trying to pack something in a box. If and you are trying to pack a different size, shape objects in a particular box, when you are trying to pack it, if you are not properly organizing the things in a particular box, definitely finally you will be ending up with packing very limited number of things in a particular box. So you need to check it. Nowadays people, that is why now the products are fabricating in such a way that it can be folded. It is flexible even in shape. You can try to fold in any way, then you can try to organize as many things as possible in a single box, so that you can go, you can travel with a single box. No need of too much of luggage or too much of weight. It is. So organizing the things means how the particle shape or size or product will be helping to cover the area which is available. So if the particle size is small, so how many particles can be covered in a particular surface? So that is one thing, you can take it as an example. Then how the size of the particle, especially small size of the particle, will be impacting on the area coverage, then volume, especially how much volume can be covered with the available things. Then based on that, how the properties can be changed, that you can check it. As the nanoparticles are added to any common material, it is completely refining the grain. Once the grain is refined, automatically properties will be, structure will be changed. And these structural changes may happen either intragranular or intergranular, and which will be improving the boundaries of the grains. And because of changes in grain boundaries, automatically properties will be improved. So there are two examples which were done by other researchers. For example, addition of 3% weight of nanosilica to concrete can improve its compressive strength, bending strength, and splitting tensile strength. So that is what already I have mentioned. Whatever may be the type of the product, whether it is related to construction, related to electronics, related to IT field, related to mechanical sector, related to medical sector, whatever it is, it will be subjected with various mechanical factors, or it will be undergoing mechanical environment when it is used by the customer. So in that particular case, how good the product as a end product, how it is sustaining its life even though it is getting subjected with various mechanical environment. So sometimes we may apply the force, we may hit, sometimes we may press, sometimes other things will be suddenly loading, sometimes repeatedly the product will be getting affected. So like this, it will be cyclic loading, low cycle loading, and at the same time impact of heavy loads, and sometimes people will be trying to pull the objects, and sometimes compressing the objects between the two different objects, whatever it is. All these things will be determined by mechanical properties, how good the particular product with respect to mechanical properties. When the product is getting manufactured, so manufacturer should be careful about the mechanical properties of the particular material before it is sending to production department. Then another example is adding 3% of nano oil palm empty fruit, which will be improving the composites and improving especially epoxy composites, and it will be improving the tensile strength and elongation at break, and at the same time it will be trying to help for improving the impact strength also. And you can see these are the some of the examples with addition of various nanoparticles, how in general mechanical properties are improving. You can see how the hardness is improved, fracture toughness, fracture strength, ultimate tensile strength, and impact strength with respect to addition of various nanoparticles. Especially all this data is from earlier researches I have taken. So based on this, you can show here almost all the properties are impacting with respect to this nanotechnology or nanoparticle. So not only the mechanical properties, it will be even impacting with nano coatings also. Because of nano coatings, which will be helping for enhancing toughness and also improving the lubrication or wear resistant properties, and hardness, elastic, modulus, all these things already we have discussed. And when it comes to the properties or the materials which are very common for fabricating various materials, especially, so if you take nanometals such as gold, silver, zinc, whatever it is, which have been widely used to improve physical, mechanical, and chemical properties of various materials. So these elements are adding as alloying elements to improve mechanical properties of other materials, including paper, archaeological stone, paint, wood, and medical equipment also. So all these material properties are improving physically, chemically, mechanically, especially because of this nano size, the term called nano it is. If you observe, nano silver and nano copper can improve antibacterial properties of commercial particle board and increase its lifespan also it is. And if you add nanometal compounds, which will be helping or which can be used as a catalyst, and also antibacterial and antiseptic research. So all these elements, because of nano size in particle in nano size, which will be helping not only in mechanical properties point, even other properties also. So not only metallic parts, even when it comes to non-metallic parts, many researchers, they have focused on improving the properties of non-metallic materials also, especially in construction industry. This nanotechnology is showing a lot of impact in improving the properties, especially mechanical properties of all the constructional materials, especially related to cement or any concrete, nano concrete, nano cement. So in construction industry, especially when we are trying to construct the house, we'll be having a lot of expectations. So a lot of expectations not only in physical design of the house, even functional features of the house. Functional features means ventilation, temperature control, environmental control. So many factors will be trying to expect from the particular construction, whatever material you are trying to use in constructing a building. So of course, physical appearance is important based on your taste and preferences. That is secondary. But when it comes to function, when you are trying to stay in a particular building, especially according to Indian climate, I'm telling. So all the seasons are completely different. So we need to adapt our life towards the particular season. So how comfortable your building or your construction, so that it is automatically environmental control. In such a way, the material property should be improved. Nanotechnology is helping to improve material properties in such a way that the materials, whatever you have used for the construction, this environmental control means material will be helping to control environment automatically. In such a way, people are doing research. For example, if you observe, nano silicon has excellent properties such as high melting point, high hardness, and high chemical stability. It is even promising for improving the performance in cement-based materials, all other cement-based materials. And addition of nano silicon could produce an increase in compressive and flexural strength of cement mortar. It is so not only environmental control, even the lifespan of the construction materials. That also you have to check it. If you observe some of the buildings, because of improper quality of the materials, during short period of time, we'll be observing the cracks. Even sometimes the building itself will be collapsing in a short period of time. So all because of material, the material features or the properties which was used for constructing the particular building. So that is why this nanotechnology or nanoparticles will be helping to improve the properties when you are trying to construct, especially not only for metallic materials, even for non-metallic materials. Aside from even non-metallic materials, even there are some inorganic materials also, and scientists or researchers are many of the people are working in organic nanomaterial research. If you observe, some of the authors have used graphene oxide for improving polyvinyl alcohol nanofiber to increase the degrees of crystallinity and also tensile strength. It is, and people, they have even used same graphene oxide for improving nanofibers, which can be used as a hot template to assist the growth of titanium oxide. So titanium oxide means because of environmental impact, it is one of the surface corrosion impact on many of the materials or non-metallic materials. So this particular graphene oxide will be helping the many products to protect the surface, especially from formation of titanium oxide. So when it comes to aerospace materials or aerospace field, this nanotechnology having lot of impact on aerospace materials. When it comes to aerospace products, especially aircrafts, whatever it is, the important feature of aircrafts or the fabrication of, when we are trying to fabricate the craft or any other aerospace products, whatever it is, in that case, the important feature or the property which people will be expecting is less weight, because it should fly. It should fly. If the weight is high, automatically, accordingly, you need to arrange remaining parameters, designing parameters. If the weight is high, automatically fuel consumption will be high. And that is why the important feature or property with respect to aerospace products is lightweight. So how to manipulate the matter without compromising other properties, but we need to get lightweight. The material should be lightweight, but still other properties should be same. So then people started working or adopting this nanotechnology for reducing the weight of the particle without compromising other mechanical and non-mechanical properties. So that is why nanotechnology is showing lot of impact on improving aerospace material properties, especially in improving strength to weight ratio. So material will be light in weight, but strength is not compromised. So it will be giving maximum possible strength, whatever is required. But at the same time, people are trying to reduce the weight, and they have succeeded in reducing the weight because of adoption of nanotechnology. So how, for example, if you observe the properties, especially related to aerospace materials, it is one of the biggest sector, aerospace. It is not only strength to weight ratio or mechanical properties. Even nanotechnology, people are trying to implement or adopting for reducing even environmental impact due to aircrafts. Environmental impact means especially related to carbon footprints. Environmentally means what is the carbon footprint or pollution because of aircrafts. So that then with respect to that, even nanotechnology people are working how or nanotechnology can be adopted so that environmental remedies can be taken to protect the environment or to reduce the pollution in the environment. So now people are trying to work on these things, and we can see here nanostructured metals or materials, whatever it is, which will be having the particles or crystals at nanoscales, which exhibits considerably improved properties compared to other counterparts with microscale or macro scale, whatever it is. So because of this nanoscale crystalline structure, people have noticeable and they have observed properties which are very crucial to aerospace applications, especially yield strength, tensile strength, corrosion resistance, and a low density to facilitate substantial reduction in structural weight. This is very, very important. The complete weight of the aircraft should be as much less as possible. So we need to work in such a way. So, and another important thing is corrosion resistance. So it will be moving in the air, so traveling air. So when the flight is flying in the air, there will be a lot of environmental impacts. So then how to protect the external surfaces, of course, even in internal surfaces, especially with respect to impact of various environmental factors in terms of corrosion. So this nanotechnology even helping, or nano coatings are helping to protect various parts of aircrafts, especially from corrosion. And at the same time, because of demonstrated nanostructured metals, not only improving or enhancing the properties, and it is even also exhibiting uncharacteristics of conventionally sized materials. Of course, already people have experienced, and many researchers and scientists working on developing nanostructured titanium, nickel-based alloys, which is very, very demanded or prominent in aerospace industries, and even a combination of these two titanium nickel alloys, which will be providing extraordinary yield strength and also super elastic properties, which are highly required, especially for aerospace materials. And already I have mentioned related to corrosion and tribological properties, both for manufacturing and non-manufacturing sector also. So this nanotechnology is showing some impact on reducing the wear resistance, improving the wear resistance, and also improving the anti-corrosion properties. So another important trend or field of aircraft materials, it is improving the anti-corrosion properties. This is another important requirement actually. To improve these anti-corrosion properties or tribological properties, now and aerospace industries, they are adopting nanotechnology in terms of coatings, not in terms of developing materials, coatings over the materials. So nano coatings, how it is helpful for protecting the craft surface from various environmental conditions. It has shown positive results, and people these aircraft industries try to adopt nano coatings, especially magnesium alloys. So magnesium alloy means it is very less in weight compared to all other metals, all other alloys. Magnesium is very, very less in weight, but even though it is less in weight with other superior properties, but still work is not that much up to the expectation level with the magnesium alloys because of reaction. So it is when it comes to contact with the oxygen, it will be flames will come. It is highly flammable material. That is the only thing. Chemical reactivity of magnesium. That is because of this chemical reactivity of magnesium. It is not that much adopted in various industries, even though it is superior with all other properties. It is the basic reason. Now people are trying to go with this magnesium coatings for improving the durability of the material from various environmental factors. And even magnesium alloys, already I have mentioned, which is very, very lighter than steels or aluminum, and they are compromised by their susceptibility of corrosion, but caused by high chemical reactivity of the magnesiums. And nanomaterials used as an alternative to chrome anti-corrosion coatings include silicon and boron oxides, and also cobalt phosphorus nanocrystals. It is so. And when it comes to not only particular industries, especially in manufacturing sector, even when it comes to day-to-day materials and processes, nanotechnology, it has shown, and it is greatly extending its advantages or benefits in day-to-day materials, whatever we are using for various products. So if you observe some of the examples, nanoscale additives or to our surface treatments of fabrics can provide lightweight ballistic energy deflection in personal body armor, and it can help to resist wrinkling, staining, and bacterial growth, especially in fabrication industry. And even nanoscale films on eyeglasses, computers, and camera displays, and even on windows and other surfaces can make them water and reduce repellent, anti-reflective, self-cleaning, resistant to ultraviolet and infrared light. So this particular idea is taken from the nature. If you observe lotus leaf, so lotus leaf, it means because of nano-structured surface, lotus leaf structure, if the water droplet, if there is a water droplet on the surface, it will be repelling on the surface, and it will try to take all the dirt from the leaf, lotus leaf surface. Because of this, lotus leaf will be always spotless, even though it is growing in a muddy water. The same technology, so same structure people have adopted for fabricating different devices, which will be self-cleaned devices, especially window panels, computer screens, eyeglasses, sunglasses, whatever you have taken. The same structure people are adopting. It is called repellent structure or repellent property, which will be self-cleaning. Automatically, the surface will be cleaned itself. So, and another important thing is nanoscale materials are beginning to enable washable, durable, smart fabrics. Nowadays, people are trying to, especially for military people, soldiers. So they'll be working in a very, very abnormal atmosphere. Whatever fabric or clothes they are using, so it should be as much light as possible. At the same time, it should protect the soldier even in very, very abnormal environment. Then how the fabric property should be, so that it will be controlling the human temperature, body temperature. Means it will be protecting the human body according to the environment. So in such a way, people are trying to work on. Actually, one of the professors from VIT itself, he tried to work the caps, whatever is soldiers are wearing, whatever they are using now, it is heavy weight, and they'll be traveling kilometers by wearing the entire kit. So that means they'll be holding or they'll be carrying n number of certain kgs of weight. So in addition to this, means just to imagine how discomfort it is if you want to carry the continuous weight with complete pack. If you observe, so when you are sitting, if you are going to college, immediately after coming from the college or office or wherever it is, immediately we'll try to refresh. But these soldiers, they'll be working continuously without any break, and even they won't even get the time to change their dress also. So then how the particular fabric should be, so that it will be comfortable even though they are walking or traveling for a long time. So we should protect them from all kinds of environmental impacts, and at the same time it should be as much light as possible. So now this nanotechnology, people are trying to adopt fabricating smart fabrics, which is is it washable, durable, and at the same time it is equipped with flexible nanoscale sensors and electronics with capabilities for health monitoring, solar energy capture, and energy harvesting through movement. So now the fabric is designing in such a way that because of these nanoscale sensors in a particular fabric, so it will be giving the health monitoring, that means body condition of the particular person, and it will be trying to grasp or grab the solar energy and trying to harvest the energy which is needed for, means now the particular fabric will be helping to harvest the energy, and which we can use for charging our mobile phone also. In such a way, people are trying to fabricate, and it is easily washable and also durable. It is in such a way, nanoscale materials are trying to incorporate even in fabric industry or garment industries. And when it comes to automobile field, of course, again here also in automobile field, everyone will be thinking for reducing the weight of the vehicle for improving fuel efficiency. That is one important problem actually. So how to reduce the weight? Again, people will not be compromising. They don't want to compromise in terms of design features. So as per the customer's requirement, the design of the vehicle should be, there should not be any compromise, but still manufacturer and even of course as a customer also, people will be expecting fuel efficiency. So how to improve fuel efficiency without compromising the design features or other parameters? So again, people are adopting this nanotechnology. So which will be helping to reduce the weight because of particles or the material which is fabricating at nanoscale. So because of this, properties will not be compromised or changed, but still trying to reduce the weight. And lightweight cars, trucks, airplanes, boats, spacecrafts, whatever it is, which will be highly significant in fuel saving. And nanoscale additives in polymer composite materials are being used in baseball bats, tennis rackets, bicycles, motorcycle, helmets, automobile parts, luggage, power tool housings. So everything. So to make each and every part as much light as possible and also stiff, durable, and highly resilient it is. And people are trying to adopt carbon nano sheets or tubes, especially for next generation vehicles. For example, lightweight materials and conductive materials making highly ideal for various applications, especially in electromagnetic shielding and thermal management also. And still so many examples are there. It is nanostructured ceramic coatings, which exhibits much greater toughness than conventional wear resistant coatings for machined parts. Now people are adopting coatings, especially on ceramic parts, which will be highly wear resistive compared to other conventional coatings. And even nanotechnology enabled lubricants and engine oils also significantly reduce the wear and tear, which can significantly extend the lifetime of the moving parts. Everything from power tools to industrial machinery also it is. So then nanoparticles even increasing in highly used or increasing use as a catalyst to boost chemical reactions also. So which will be reducing catalytic materials, quantity of catalytic materials and necessary to produce desired results, and it will be trying to reduce the cost.
I request please participants mute yourself and your video, switch off your video. I'm sorry, ma'am. Please continue.
Yeah, no problems. I thought someone is asking doubt, that's why I stopped.
No, ma'am. No. Please.
Okay, sir. Okay. And even nano-engineered materials like superior household products such as degreasers, stain removers, environmental sensors, air purifiers, filters, whatever it is, antibacterial cleansers. So each and everything nowadays trying to fabricate with nano-scaled particles, which will be easy to mix, which will be easy to remove, which will be easy to absorb. So many things it is. Absorption, adsorption, solubility, each and everything it is. So dust removal means absorbing of the dust. So based on so many household activities, requirements from household activities, people are trying to fabricate so many products with the nano-based structures. And even surface properties already I have mentioned. These nano coatings are highly helpful to protect the surface from various wear conditions, different types of wears, environmental impacts also it is. Already I have mentioned particle size and surface area plays a major role in interaction of the material with the biological system. So if you decrease the size of the material or particle size, which will be leading to an exponential increase in surface area, especially relative to volume. So because of this, nanomaterial surface more reactive on itself and to its contagious environment. Already I have mentioned for this particular one, especially related to surface properties, one best example is lotus leaf. Lotus leaf, how means the surface itself is highly reactive because of nanostructured particle on the surface. So now people are trying to adopt the same technology for the various surfaces, which is self-cleaned, self-reactive for the various environments. And even when it comes to electrical properties, now people are more bothering about especially energy storage, energy related devices, how flexible the display technology, and also smart clothing, field effect transistors, so many things. So now whatever TV you are using, LED screens, DVD players, so whatever it is. So people are bothering about the size, of course. At the same time, it should be as much smart as possible. That can be done using some kind of smart devices and electric circuits. So here, if you observe the storage devices, especially previously people try to store in floppy disks, then it is try to modify it into CD, DVDs. Nowadays it is pen drive. But what is the size of the device, you can check it here. But what is the storage capacity? So same thing you can observe, all because of all this comfort or size changes are happening just because of nanotechnology only. So here this nanotechnology even helping for improving the means flexibility, electrical conductivity, and also the strength, which are exclusive parameters, especially in designing any type of the material with respect to electrical properties. Commonly, insulation techniques are used, especially for conductive materials, which is covered in flexible elastomer, especially in electric wiring. Nowadays, this nanotechnology is adopting for fabricating even nanowires, which will be helping for reducing power loss, especially during the power transmission. So now people are trying to make typically non-conductive materials or nanomaterials, especially in wiring or this cable, which will be reducing the power loss during the transmission. And with respect to heat transfer properties of nanomaterials, nowadays almost all electronic and communication technologies, which are showing witness with respect to the growth in features of the products, especially based on nanotechnology. You can see here. So most conventional coolant fluids have limited heat conductivity, but if it is a nano fluid, the heat conductivity, how the changes has been taken place, especially in terms of conductivity. So small particles, weightless, and therefore less likely to undergo sedimentation. And at the same time, it is stabilizing. If stabilizing agents are used, the fluid may remain stable for months at a time. These nanoparticles are ideal for use in microchannels, which handle large heat inputs because of their high conductivity and also high conductivity and aspect ratio. So their use avoids danger of clogging that is associated with large particles. If the particle size is large, especially in microchannels, there will be clogging. So which may cause some kind of problems, especially. In addition, because of these nanoparticles, this clogging can be avoided. In addition to small particle size, reduces wear, tear, and even which will be extending the life of the products. And especially related to temperature and other concentration, already I have mentioned, these nanotechnologies, people are trying to adopt for temperature control on environmental control also. I have given example with respect to construction materials, how these nanoparticles are helping for improving the material properties, which is environmentally controlled, which will automatically control with respect to environmental factors. That is one thing. Then computer memory and improvements with nanotechnology. Already I have mentioned whatever drives you are using. So how the storage is taken place. Hard drives used as a memory in computers consume more power and have more chances of failure than solid state memory states. So now people are trying to change the circuit and the material, whatever you are using. So all these things now they are trying to make everything small in size so that power consumption will be less and there will be more storage space. And failures also will be very less. So that is why please don't think this nanotechnology it is only for mechanical industries. It is also useful for non-mechanical. So in electronics and IT applications, if you observe, it has shown it has given greater contribution towards both electronic sector and also IT sector in by changing or by making drastic change in shape, size, functioning of the particular products, various products, especially used in electronics and IT applications. If you observe transistors, the basic switches that enable all modern computing, so have got smaller and smaller through nanotechnology. At the turn century, so if you observe this thing, the typical transistor was 132 to 50 nanometer in size. So at the same time, these electronic devices, because of this nanoscaled structured particles, so whatever device we are trying to make, it is trying to give maximum flexibility and bendable, foldable, rollable. So already, I think many of you are aware that now whatever laptop you are using, so it can be rolled and you can keep it in your pocket as a pen. So all this because of technology. Of course, technology means here not only the machining or fabrication technology. Already I have mentioned this machining or fabrication technology. It is only a support, but this support making the idea feasible because of nanotechnology or the concept called the nano in manipulating the material properties. Because of changes are manipulating or developing the material properties. So now whatever product in whichever shape you are trying to fabricate, in whichever size you are trying to fabricate, so we are able to change the product in all the shapes in different directions according to our convenience, either for handling, either for usage, either for storage, whatever it is. when you are trying to handle, how convenient the shape and size of the product. When you are trying to store something, how convenient it is to store the particular product. When you are trying to use during the usage, how comfort to the particular customer or the operator with respect to shape and size. Of course, functioning is important. So here, these nanoscaled structures will be helping not only improving the functional properties of the products, but also helping flexibility in carrying, storage, and even other applications. Means it is providing extra value in terms of convenience and comfort to the customers because of the changes in structure. We are able to change, means we are able to change the shape of the product in different ways according to our convenience. Wherever you are at the place, means wherever you want to take, wherever you are trying to utilize, wherever you want to store, accordingly we can try to fold, or we can even bend, we can even stretch. So many things we can do accordingly. Means the space, the product can fit in a particular space. So that all this flexibility and all this comfort is just because of nano, the term called nano in the technology, because of the changes in matter particle, especially at the nano scale. This much flexibility is, means we are able to get, means we are able to enjoy the flexibility in even physical shape also. So even many of the computing or electronic products, flash memory chips, smartphones, thumb drives. So whatever you are trying to use, especially if you are whatever earphones we are using. So if you keep on using the earphones throughout the day, of course there will be certain kind of fungus formed in the human ear. So then what should be the material used for these earphones so that it will not harm the human ear? So the material, immediately how to think about antibacterial coatings. Okay, so or antimicrobial coatings. So because of this, it will not cause for any hearing aids, and it will not cause any kind of infection also. Similar way, even whatever keyboards we are using, the smartphone screens, so printers, smart cards, even ATM cards, visiting cards, anything, whatever it is, how the surface should be, what kind of material it is, so that it will not. So because of continuous usage. So how many times you will be touching your mobile phone or mobile phone screen in a day? So then what is the impact of continuous touching? Means continuous contact with your finger on the screen. So what is the impact of the finger? So you can think it. So it is a screen, simply we are swiping, right? No issue. So mechanically we are, means when you are trying to use, we are comfortable. But what is the impact of that screen material on your finger? That you have to check it. How the surface of the screen is impacting on human finger. Is there any kind of bacterial infection which will be formed between these two because of continuous contact? Even when you are typing on the keyboard, how it is impacting. So you have to check it. So not only mechanical properties or flexibility or convenience, even when it comes to human health point of view, how the material will be supporting for reducing all kind of infections, even though there is a continuous contact of human body part with the particular material. So that also we need to check it. So then medical and healthcare applications already I have mentioned. So nowadays all kind of treatments, all kind of diagnosis, even the devices, whatever doctors are using for various surgeries or for other medical applications. So whatever it is, this nanotechnology, not only in terms of physical parts which are used by the doctors, is even also showing impact on making the drug or the materials, means the medicines, whatever it is. So the disease may be very big, the tablet size is very less. Very less. So you need to think immediately. So the disease I am suffering from so and so disease for last 1 month, but you are giving so small size tablet. So that means that much impact on entire human body. Just imagine what is the size of your body, what is the size of the tablet. Here it is. So all because of nanotechnology, people are trying to make the medicine so that it is comfortable to take. If this big size medicine, if the tablet size is around 10 centimeters, so is it possible to take? Definitely not. It will be very difficult. That is what. So whatever objects or products we are trying to fabricate, so whatever comfort we are enjoying, all because of technology only. Being an engineer, being a technologist, we should be proud, because entire world, whatever people are enjoying in terms of comfort, convenience, or any other thing, so it's all because of invention. Means in one way or other way it is. So that invention is possible or feasible, and it is it is applied to various fields only because of technology. Here, nanoscience, it is showing maximum greater. It has extended its contribution to a greater extent in medical and healthcare applications. It will be helping to detect the disease, to diagnose, and to treat, and also it is helping even in various shapes and size of medical devices, surgery devices, which we are using. So, for example, whatever knife people are using for making surgery. So then what is the material? So what is the particle size of the particular material? And at this, so that when the human skin gets cut with the particular material, how this nanostructured microstructure will be helping to the means will be helping, so that there will not be any harm to the human skin with respect to the material, with respect to the structure, and with respect to the environment also it is. So that is why it is not only helping for fabricating the physical parts, it is now even also helping to detect the disease, and it is also even helping for diagnosing in advance, sorry, for detecting in advance, for diagnosing at which stage, and also for treatment also. And people have adopted various applications in medical sector and also even non-medical sector for fabricating the means for making of the medicines, for making disease detection, and also for treatment also. And nowadays even researchers are looking towards nanotechnology for improving vaccines, so including vaccine delivery without the use of needles. People are trying to provide working on nanotechnology for inventing or for working on vaccine delivery without uses of the needles, and they are even also working on creating a universal vaccine scaffold for the annual flu vaccine, so that would cover more strains and require fewer resources to develop each and every year it is. And another important thing is this nanotechnology is highly helpful, especially in cancer treatment. Whatever cells and whatever treatment people are using, either through laser or whatever it is, so it is completely because of nanostructured cells, which will be helping to for the treatment, for also for the detection of especially cancer. And when it comes to energy applications, now many of the industries are bothering about energy storage, because resources are very limited. If you are keep on using all the resources, one day it will be, so everything will be exhausted. So what are the renewable resources available? So then what are the energy storage devices, and what are the different ways we can harvest the energy? So now people are bothering about the technology, and people are trying to improve the properties of the material, so that the material will be helping for energy storage for longer time. That is the one important thing. So now this nanotechnology is adapting even for energy applications, especially in manufacturing batteries, which will store energy, and also for vehicles, in reducing the fuel consumption in vehicles, and also for power plants through higher efficiency combustion and decreased friction. And people are trying to develop the wires in containing carbon nanotubes that will have much lower resistance than high tension wires, which will be helping to reduce the power loss, especially during the transmission. And nanotechnology is even incorporated in solar panels. So nowadays, there is a one kind of myth that solar panels means it is very expensive. So now research is going on by adopting nanotechnology, even with respect to solar panels or solar cells, which is less expensive, which will be very cheaper, and people are trying to make a coating over the solar cells so that it will be absorbing the sun rays for harvesting or for converting the electricity here. It's also being used and developed in new kind of batteries that are quick charging, more efficient, lighter weight, the high power density, which will hold electrical charger longer time. So then epoxy containing carbon nanotubes is being used to make windmill blades, which are longer, stronger, and lighter weight than other blades, and also to increase amount of electricity that windmills can generate. Of course, in all the applications, physical shape and size is also important. In addition to that, what material we are using to fabricate the particular part, that is very, very important. How this nanotechnology is helping to improve the functioning of the particular part. So that only we are trying to check it. And even in energy harvesting, people are trying to develop thin film solar electric panels that can be fitted onto computer cars. And flexible piezoelectric nanowires woven into clothing to generate usable energy on to go from the light, friction, and or body heat to power mobile electronic devices. Already I have mentioned people are trying to fabricate or trying to weave a product fabric which is means which will generate the heat that can be which will generate the power that can be used for mobile charging. Similarly, various nanoscience based options are being pursued to convert waste heat into computers, automobiles, homes, power plants, etc. to usable electrical power. So whatever heat is getting waste in various sources through various sources in various forms, that people are trying to convert into useful electrical power. Environmental remediation, already I have mentioned how people are very cautious about environmental concerns because of warning signal, especially with respect to pollution level in our country. So we need to be very careful about all environmental concerns when you are going to fabricate something, use something, decompose something. So from birth to till grave. So we have to check it. So how sustainable the part or the material what we are trying to fabricate means giving birth. Then when you are usaging means what is the life of the product, how long it will be useful. During usage, how sustainable it is. Then after usage, when you are trying to throw or decompose something, so then how sustainable during decompose. That also you have to check it. So now people are trying to work on nanotechnology, how it is helpful to protect the environment, means towards environmental concerns, so that we are able to improve the sustainability or we are able to improve the means green level environmental factors, so that with respect to materials, which material is highly suitable for fabricating so and so part, highly sustainable. Now people are working on various products during usage. There should not be environmental impact. Then at the end of the period, when you are trying to throw the product, how sustainable it is again. If you take e-waste, how many mobile phones, desktop, laptops, whatever it is, everything. So if you dump it in a place, so how long it will take to get it decomposed. So what are the materials we are used to make such kind of products? At the stage of decomposing or waste management, how it is showing impact on environment. So then, if you are able, is there any kind of impact of nanotechnology during fabrication, during usage or implementation, or at the stage of decomposition? Is it helpful for improving sustainability at 3 different stages? Now people are working even in that way also. And I can give you one important example. So researchers have developed a nano fabric paper towel, which is woven from tiny wires of potassium manganese oxide that can absorb 20 times of its weight in oil for cleanup applications. Research have also placed magnetic water repellent nanoparticles in oil spills and used magnets to mechanically remove the oil from the water. So this is because of industrial waste. So industries, they are simply releasing their waste into the rivers. So because of this, water is getting polluted. So how to treat the water or how to reduce harmful agents from the industrial waste. So that people are trying to use or trying to mix some kind of nanoparticles which will be absorbing the oil content in the industrial waste, so that the pollution, we are trying to reduce at least level of the pollution in the water it is. Then when it comes to transportation, already I have mentioned, if it is a vehicle, mostly will be bothering about the lighter, safer, smarter and more efficient vehicles. Whatever may be the type of the vehicle, on road, off road, means on the sea or air, whatever it is. So should be lighter weight and safer, smarter and more efficient. So why it is safer, how nanotechnology is helping in terms of safety means, of course, with respect to the body parts of the particular vehicle, what material is used and how reacting, means how it is resistive towards environmental impact, so that it will be protected from all kinds of effects. when it is getting traveled. That is why you have to think even material structure, even from safety point of view, smartness, and also more efficient vehicles. And non-engineering of aluminum, steel, concrete, and other cementous materials, and the recycled forms offer great promise in terms of improving performance, resiliency, and longevity of highway and transportation infrastructure components by reducing their life cycle cost. So not only the vehicles, even whatever infrastructure is required, especially in terms of transportation, people are trying to improve the life cycle with minimum possible cost, and other sensors which will be helping and which are providing very cost effective continuous monitoring of structural integrity and performance of bridges, tunnels, rails, parking structures, and payments over time. Nanoscale sensors. Here I am not explaining in terms of nanoparticles for the construction, even for monitoring. What is the life of the particular infrastructure, especially during transport? For example, what is the life of the bridge? So what is the life of the tunnel? What is the life of the railway track? So what is the life of the parking structure, pavements, whatever it is? These when people are trying to construct it, it should be inbuilt with some kind of nano sensors, so that it will be intimating or noticing the life, or if there is a chance of any damage in near future. So we need to get, that means we are trying to provide smartness by adopting these nanoscale sensors during construction, so that we'll be trying to know, is there any kind of damage to the particular infrastructure, means to the particular bridge or tunnel or whatever it is, so that we are able to reduce the risk of the human when they are traveling on a particular bridge or on a road or on a tunnel or what it is. So these are some of the examples, especially. There is still so much of work is there. I think I thought of stopping here. If you have any doubts, we can discuss.
Thank you, ma'am. Now we'll go with the Q&A session, ma'am.
Yes, sir.
I will read the question from chat box. Some of the questions we have received.
Yes, sir.
First question from Arnapan Narayana. How to overcome the settlement of nanoparticles in nanofluid, even though surfactant is used?
Okay, surfactant is used. Settlement of nanoparticles means it is not settlement. We need to think the structure of the particles in such a way that it will be soluble in the particular fluids, or we need to go for certain kind of other particles which will be absorbed, so that we can try to remove from the fluids.
Okay, ma'am. Ma'am, next question from the same professor. While handling the nanoparticles, what are the safety measures will follow?
Safety measures in the sense we need to think about the nanoparticles, sir.
Yes, ma'am. Yes.
No, safety measures at which particular point of time?
While using nanomaterials or nanoparticles.
Of course, sir. Nanoparticles we are not using as it is. It is a matter which we are trying to convert into some other product, right?
Okay.
No, actually, nanotechnology we are not directly using. So we are trying to adopt this technology for modifying the particle size or microstructure of the material, which will be helping to improve the properties in different ways.
Okay.
That is what already I have. Yes, sir.
Yes, ma'am. Please continue. Yes.
No, sir. That is what I have mentioned. Nano sensors, so which will be completely invisible and which will be helping to the security people at airports, even for the military people, to absorb some kind of threats. Means the size is very small, the particle size, so that we are able to fabricate the products even at nanoscale, means very small scale.
Thank you, ma'am. I request once again participants, you can please unmute yourself. You can ask question directly to our resource person, or you can type your question in chat box. We will ask on the ground.
Okay. Good evening, sir. Am I audible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Rajalakshmi, ma'am. Good evening.
Yes, ma'am.
This is Kaulinya from JNTU.
Yes, ma'am.
I hope you remember me. SVU, chemical.
Okay. Okay.
Okay. Okay. You have given nice presentation, ma'am. Thank you so
Thank
much.
you.
Lots of information is there, and you have
Thank you,
given
thank
complete
you.
notes of nanotechnology, so which will be useful for our students if this PPT is shared to us.
Saujanna, I'll talk to you personally.
Yeah, sure, ma'am. Nice
Mhm.
presentation.
Thank you,
Thank
thank you.
you so much. Thank you,
Sir,
Tejas
she is
sir.
my classmate, batchmate.
Thank you.
Thank you, ma'am. Thank you for
Yes,
your
sir.
excellent feedback, ma'am. Thank you.
Sir,
Thank you.
I hope it is the presentation of the content, whatever I have used, presented. I think it is little bit useful, at least to the participant. I don't know to what extent I have met your requirements or
Yes, ma'am. It has
expectations.
given more clarity, ma'am. Yes, ma'am.
Actually, a lot of content is there. Due to the time limit, I have covered little faster some of the
Yeah.
issues, and I have
Yeah.
some experimental results also I thought of showing. But to cover various fields, how it is impacting nanotechnology, I thought of explaining very briefly. So in future, if anyone is requiring any help, I'm ready to help, sir, especially in terms of research or projects, anything.
Thank you,
Thank
ma'am.
you, ma'am. Thank you,
Yes,
sir.
sir.
I request once again participants, please unmute and we can ask questions.
Madam. Hello.
Yes,
Yes, sir.
yes, sir. Yes, sir.
Good afternoon, madam. This is
Yes,
Naresh
sir.
from
Naresh,
Digital
yes, sir. Yes, sir. Sir.
Hello.
Yes,
Can you hear me,
sir.
madam?
Audible, sir. Audible. Yes, sir.
Madam, it was a very nice presentation, madam.
Thank you,
I
sir.
got very much information from this.
Yes, sir.
So, my simple query is actually, I've been attending this workshop. As also, I attended first phase of this one.
Yes, sir.
So,
Yes, sir.
most of the researchers were focusing on utilization of the nano particles or nanotubes or anything else which is in the form of nano
Yes, sir.
size
Yes, sir.
to improve the
Yes, sir.
properties of the some applications so that it will be applied in so many fields. That is what
Yes,
and I understood. But no one is mostly trying to fabricate the nanoparticles.
yes, sir. Yes, sir.
Yeah.
Actually, that is it is better to take another session because fabrication technology is having greater impact on properties of nanoparticles. So the way
Yes,
how
yes.
we were fabricating the material, it will show a lot of impact in terms of temperature or in terms of time, whatever it is. It is having
Yes.
lot of impact. I think it is better to have a new session on that because if I combine both with respect to the once the particle is ready, then how it is impacting on end product, that is completely different.
Yes, madam.
So
I accept.
during fabrication, so we need to focus a lot, sir. Actually, there are different fabrication techniques, and what are the fabrication parameters? How it is impacting on the properties? That is completely different, actually.
Yes, madam. I
I
accept.
think
What
hope
is my-
you organizers may have another may conduct another session, especially only means particularly on fabrication, nanoparticle fabrication.
Yes, madam. My query is now,
Yes, sir.
can you please throw a light on methods which can be done in a with a simple equipment? Because
Yes, sir.
people presented complicated techniques which require so much huge equipment.
Okay,
Like
sir.
CVD,
Sir,
PVD.
you can very simple means you can go for ball burnishing, rolling process.
Okay.
Particle size, sir. To reduce it, you can go for ball burnishing process for reducing the particle size.
Ball furnishing, madam.
Burnishing, ball burnishing. Yes, sir.
Okay, okay.
Okay, that is one.
Anything
Another
else,
one,
madam?
rolling process. Rolling
Okay.
process, which will be changing the structure.
Okay. Whether we
Okay,
can
so-
prepare nanoparticles from that, madam? With
Yes,
ball
sir. Yes, sir. We
furnishing?
can prepare. That is what we can make even powder. So that means powders from the billets. Then particle size also can be changed. You can even observe that.
Okay, ma'am. Thank you very much. One thing is, what is my main request is, for able to get one method which can be done by any individual, so that
Yes,
they can
sir.
prepare their own nanoparticles to perform the
Yes,
research.
sir. That is best. Yes, sir. Yes, sir.
Because
Yes,
we are always purchasing, they are very highly costly, so that we can't do research.
No
for a
need, sir.
simple thing.
Actually, with very means very cheaper methods, there are even very less expensive means cheaper or economical methods which are available for fabrication of nanoparticles. So
Okay,
only
madam.
thing is we are not aware. That is the only thing.
Yes,
Already I
madam.
have
That is what
mentioned. It is
I
not a
require that
new
input,
technology.
madam.
People have used long back. Only thing we are
Yes,
not
yes.
aware. Yes, sir.
Yes. Can you please
No, sir. With
share
your
your
own setup, you
suggestions?
can fabricate. It is not a big issue.
Yes, madam. So I will be in touch with you
Sir?
in mail, madam.
Sir?
I will be in touch with you mail, madam.
Yeah, sure, sir. Yes, sir. Yes, sir.
So,
Yes, sir.
please let me know
And
about
whatever
those methods.
facilities we have at VIT, I'll try to support, sir. No problem.
Definitely, madam. Definitely, madam. Thank you, madam. Thank you very much for your talk.
Yes, sir. Yes,
Thank
sir.
you, madam. Bye.
Okay.
Ma'am, thank you, ma'am. Actually, next month we are
Yes,
planning
sir.
to conduct phase 3 also. If your time
Okay,
permits,
okay,
we will
okay.
take one more session, ma'am. We will be honored. Sure.
Yes, sir. Because I have seen your schedule. Most of the topics are related to the materials and how it is impacting on material properties, all those things. I
Yes,
think
ma'am.
you must. I think it will be better if you have a session how to fabricate the nanoparticles.
Yes, ma'am. Next month we are planning for phase 3, ma'am. In
Yes, sir.
that, we
Yes,
will
sir. Yes, sir.
request you, ma'am, if your time permits, please be as a resource.
I'll try to join, sir. Yes, sir. Yes, sir.
Thank you. Thank you.
Yes.
Ma'am. Thank
Okay. Thank
you.
you.
I request once again, participants, please unmute yourself and you can ask questions. Ma'am, one more question from chat
I
box,
think.
ma'am.
Yes, sir. I think
How
Sharath.
yes, Professor
Yes,
Sarath,
sir.
how
Share how natural nanomaterials like wood-based charcoal kind of material be used in any practical. Yes, sir. It is very interesting question. Nowadays, incineration process. I don't know for waste management, sir. Especially, we are trying to go with. People are trying to go with nano coatings, especially with the charcoal during the waste management, especially medical waste. When the people are trying to burn or managing the waste, cotton or syringe, needles, whatever it is, people are, means if you take a cotton which was used for treating the patient, means cleaning the blood or whatever it is, when the particular cotton is getting burned, so there will be certain kind of toxins, it will present during the burning process to reduce, and it will give very bad odor during the burning process or management process also. So this charcoal, charcoal coating or the charcoal which is prepared at nanoscale, if you go with the charcoal coating or it is also called as carbon, this charcoal coating, it will be reducing or it will be controlling these bad odors, sir. So which will not be harmful to the operator whoever is working with the particular incineration process.
Thank you, ma'am.
Yes,
I think, one more question, ma'am.
Yes, sir.
Can we, from Professor Kavita, can we use
nano composites? Of course, that is what already I have mentioned, sir, to reduce the weight of the vehicle and also for improving the fuel efficiency and for batteries. Vehicle batteries. Now people are working on this nano composites. Definitely we can use.
I think there is no question, ma'am, in the chat box. Shall I proceed with the vote of thanks, ma'am?
Yeah, yes, sir. There is no question. No, sir.
Thank you.
Hello, can I speak, sir?
Yes, sir. Please continue.
I'm Sharath from Nasrapur Engineering College, sir.
Yes, sir, please.
Yeah, my query is another query is can this charcoal or these natural composites be fused with metals, and can we produce
Yes.
even better metallic properties like?
Of course, it can, Sharath, sir. It can be used as a coating for improving surface properties. This charcoal powder, it can be used as an oxygenated carbon.
Can we mix these natural fibers with iron? Can we produce even better steels like that?
Charcoal mixing not possible with metals.
Not just charcoal, any natural fibers are there. Many natural fibers are there.
Yes, of course. Nowadays people are working. Yes, of course. Nowadays people are working with metals with fibers. They are working both, combining to make a new composite, both for getting the properties which are strong enough in mechanical and also flexibility from fiber composites, means the fiber materials.
Can you say a few nanofibers, madam? Can you example?
Nanofibers means sesame fiber, banana fibers you can use, and even nowadays people are working with insects.
Insects, ma'am?
Means not directly insect, the liquid which is generated by the insect.
Yeah. Thank you, ma'am.
I will give you one example. I think I don't have information now. I can give you, if you have send the mail, I can send you the details.
Yeah, sure, madam. Sure.
Yes.
Can you give your email ID, madam?
I think it is there. 1 second, sir. I'll type it. Sir, I have sent the mail ID. You can contact me.
Yes, ma'am. We have received your mail ID in chat box, ma'am.
Yes, sir. Yes, sir.
Ma'am, now I will go with the vote of thanks, ma'am.
Yes, sir. Yes, sir.
Thank you very much for your excellent presentation, ma'am. It is really very informative session. We have started with the current scenario of coronavirus. What is the
Yes, sir.
manufacturing, applications of larger scale effluents, and nanocomposite coatings, tribological and anti-corrosion coatings, day-to-life materials like surface properties, heat transfer properties, computer memory improvements, electronics and IT applications, antibacterial and microbial coatings, and medical and healthcare applications, and even environmental remediation and future transportation benefits. It is really very, very detailed and informative session, ma'am. Thank you very much, ma'am. Thank you, ma'am.
Thank you, sir. Thank you for the opportunity. Hope we'll meet in future, sir.
Yes, ma'am. We are also expecting positive. We are also expecting. Thank you, ma'am. Thank you.
Thank you, sir. Thank you. Thank you.
Dear participants, our today's session it is ended now. Tomorrow we will meet once again 9:45 a.m. for tomorrow's session. Sir, Charan sir, can you display
sir,
our?
wait for 1 minute, sir.
Okay, sir. Okay.
Sir, wait for 1 minute, sir. Convenience.
No problem. Okay, sir.
Sir, good afternoon to one and all. Myself, Dr. M. Chandrasekhar Reddy, convener of this program. So I think you are enjoying the sessions. Yes, thank you, madam. Thank you for your valuable and informative and excellent presentation, Rajalakshmi madam. Thank you very much.
Thank you
Thank
for
you,
your
madam.
opportunity, sir.
Thank you, madam. Thank you. We'll see you in the next session also, madam. Yes, madam.
Yes, sir. Yes, sir.
Yes. Thank you, madam. Thank you, madam. So we have seen a lot of people are joining very late. Okay, when the session
Yes, sir.
it starts only 20 to 25 members. Okay, madam. Thank you, madam. Thank you. Where general
Yes,
instructions
sir.
are given for the participants, madam. Okay.
Yes,
Thank
sir.
you,
Okay,
madam.
sir.
Thank
I
you
will
very
use.
much.
Thank you.
Right. So when the session starts, what will happen? Only 20 to 25 members will be there. At the end of the session, we are seeing a lot of people, 130, 145, but it's not good. So what we are taught is we have an assessment. We should require 90 to 95% attendance if you want to get the certificate. And we are going to post you the 2 times in a session. First, we are going to have a assessment test, followed by again we have a feedback session. So based on these 2, we are going to provide you certificate. If you attend a minimum of 90 to 95% attendance, then only you are going to receive a certificate. So this is for your purpose only. So please attend the sessions without fail. We are going to get something from experts. So we are arranging experts from the industry, institutes, and the leading research organizations. Okay, so we are successfully run phase 1 with any disturbance, and we are seeing lack of interest in the second session, phase 2, but it should not be repeated. Okay, so last session we have seen nearly 200 to 250 members are presenting to every session, and they are given a very good feedback for us, and it is looking the lag in this phase 2 session. So anyone can show the attendance, what we have collected session-wise. So we have a what you call session-wise assessment will be there. How much time we have spent in this session for each session. Madhivanan sir, someone they can
Yes, sir.
present
Yes, sir.
the attendance
Yes,
so
sir.
that will show that to the participants how much time they have spent for the each session.
Yes, sir. Yes. In
Based
sir
on
is-
this based on this attendance only, we are going to get the certificate. So the attendance.
yes, sir. Vamshi sir is showing, sir. Vamshi sir is
See that we have every 5 minutes we have attendance. See, this is the attendance. Go to the top, Vamshi, go to the top. So how much time, at what time you have entered, at what time you have left, everything will be recorded in our Google Meet. Go. Detailed analysis will be there. Don't think that when you complete the feedback, you are going to receive a certificate. If you want to see, you can see your names against your attendance. So those who will attend 90 to 95% attendance and filled the assessment test, last assessment test, and for session-wise assessment test and feedback, then only you are going to receive a certificate. Okay. So if I have any doubt, you can ask us. Any feedback? So we are going to conduct 2 more sessions like this. This is the second phase we are conducting. As for the ACT instructions, we have to conduct offline, but due to pandemic situation and corona, we are conducting in a 4 phases. Okay, for each phase of 6 days and 2 sessions, and we successfully completed phase 1 without any error free. And this is a session 2, but we are seeing a lack of interest in the participants. So the AIT is spending a lot of amount to enrich the faculty knowledge. Okay, and we are also getting a good what you call resource persons from all over the industry institute, and we are trying to give best lectures for you. Okay. Yes. You can share to us.
Hello, sir. Good evening, sir.
Good evening. Please introduce yourself and then tell, sir.
Yeah, sir. I'm Dr. Santosh Kumar Mena.
Yes,
Actually, thank you for providing these sessions to us. What I want to tell you is, sir. Actually, I didn't attend the last session, like last phase. So I got to know from only this phase only. So I registered for this phase. So of course I'm attending the lectures regularly. So like will we be given this STTP certificate for each and every phase, or like altogether?
So it is separate. Yeah, every phase.
Okay.
Every phase.
Okay, because I
so
couldn't.
Phase wise, phase 1, phase 2, phase 3, and phase 4. We're going to give. So the what you call resource persons are also different, and the topics are also different. We're not going to repeat the same resource persons.
Okay.
Last time we have nearly 12 resource persons delivered the lecture. This time also we are going to receive 12 resource persons. Every phase we are going to give you separate certificate.
Okay, sir. Thank you, sir.
Is it clear, sir? Santosh, sir?
It's very clear. Thank you, sir.
Yes.
Good afternoon, sir.
Good afternoon.
Yeah,
Please introduce yourself.
Yes, sir. I am Arun from Chennai, sir. I'm
Sir,
working
tell
as
me,
an
sir.
assistant professor from St. Joseph College of Engineering and St. Joseph
Okay.
College of Engineering in Mechanical Engineering Department.
Yes, sir.
Yeah, I attend your program from the first day onwards, sir. It is good and
Okay.
nice organizing. The thing is, from our university, I started college, sir, online classes. It is actually from 10 to 11, 11 to 12, 12 to 1, and 2 to 3. This is the schedule we have for our online classes. We somehow manage the things and we alter the classes between 12 to 1, and remaining time we are attending the classes, sir. Maximum we are attending the classes, our online program. Also, we have to handle class. We are handling 2 subjects, sir, for our students, and daily at least 1 to 2 hours of classes are there. With 95% attendance may not be possible. Slightly it may deviate, but we are trying to attend all the sessions as much as possible. We actually our program is 10 to 12 and 2 to 4. Our college classes are from 10 to 12, 10 to 1, and again 2 to 3, sir. So we are as much as possible we are trying to attend, but 95% attendance may not be possible sometimes. Maybe deviating. All the faculty members may be having online classes nowadays, because the semester started, sir, for our semester. So that problem we
See,
have. This is
okay,
for your
okay.
kind information, sir.
Okay,
Yeah.
I understand your problem, sir. But the only thing is,
Yeah.
sir, when you are attending the program, you should have to be attentive and you should have to attend full pledged. So then only you are going to get something. One thing, and if it is possible, from my
definitely,
suggestion,
sir.
you can, if it is possible, you can alter your online classes and you take next next week.
Yes, sir. Yes, sir. I am doing.
So
I am
even
trying to alter, sir, but sometime, yeah. Actually, I am altering the classes. I am doing things like, but sometime 1 or 2 days we are not able to make it. Yeah, that's what I am trying to convey. Yeah.
Okay, sir. Okay, let it be.
Yes,
Right,
yes,
right.
yes,
Okay.
yes.
We'll consider. We'll consider.
Yes, sir. Yes, sir. Thank you very much, sir. Thank you.
Thank you. Right, right. Any other?
No, sir. Other things, you are organizing well, and resource persons are good and nice going, and no problem,
Yes.
sir. Yes, sir.
Okay.
Thank you, sir.
Thank you. Thank you.
Thank you.
Right, right.
Yes.
Excuse me.
Yes,
Sorry.
Santosh Kumar.
Yeah.
Yes.
Actually, I just wanted to give you one more suggestion, sir. If you, I mean, I don't know whether you permit me.
Yes.
So,
yeah. Tell me.
Thing is actually, so I mean, it's better if you categorize the lectures. I mean, thing is, yesterday, like I was discussing about XMCD. I mean, like sometimes the talks were about completely into nanomaterials. Sometimes like basic material science and characterization techniques. So thing is, I mean, what I felt is like, I mean, today's session, like I felt like completely, I mean, not really irrelevant, but thing is, it's not really very much suitable for me also because, I mean, I couldn't find the supporting results. So thing is, I mean, at least in the next phase, if you categorize the lectures, like focusing only one particular, object, something like that, it would be much better, I feel.
Okay, tell me which area you required. In nanotechnology, a huge area. It's an ocean.
Yeah,
so you
exactly.
suggest you suggest us
maybe like
on
I
which
really
topic
want
you required.
exactly. Actually, I really want to focus more on functional oxides. Like even the day before yesterday in the session 2, sir was discussing about many applications like in gas sensors, biomimicking. So if